Uh, Welcome to the Advances in Research and Innovation stream at SNOMED CT Expo 2025. Thank you to Debertsha for sponsoring this stream. My name is Yongsheng Gao. I'm a senior terminologist at SNOMED International. I'll be your moderator for today's session. We will address all questions at the end of the presentation. For online audience, please use the Q&A button to submit your questions to the presenter. For those in the room, in person, please feel free to just walk in step to the microphone to provide in this room, when time comes. It is my pleasure to introduce Thomas Debertsha from Berlin Institute of Health, Charité University Medicine Berlin, who will be presenting Standardizing Germany's oncology core dataset with SNOMED CT, lessons learned from a feasibility study. Thomas, over to you.
Yeah, thank you. Thank you very much. I'm Thomas. I work with the team of Debertsha at the Charité, and we're very lucky in that we get to be part of both of the Charité and working on local challenges, but also we are very lucky that our team is around 20 people, and we get to work in a lot of the German research networks and helping out there with interoperability. So essentially, our group is one of the central German interoperability hubs in Germany, and we try to do lots of help and consulting and mapping and terminology challenges. And as one of those challenges, we're currently trying to rework the German cancer reporting system, where the German cancer reporting is already pretty detailed. So every German cancer patient has a data set in the cancer registries over both the hospitals and the ambulatory practices, but it has been federated. So it has been growing from the federated cancer registries, and since about 10 years, they started to centralize their data model. There are still distinct differences, but in general, it has been great to see they have one unified data set, which is called OBDS, which is the Unified Oncological Core Data Set. And you see to the right, it's basically just a couple of data points now they are encoded. One example, this is the attention of radiation therapy, but you can already see, okay, it looks pretty German. So curative with K makes it clear it's probably not interoperable in any international sense. And it's currently an XML-based reporting, which means all those different data points are put in XML into different messages, diagnosis message, pathology message, follow-up message, and then sent to the registry. And as we're currently trying to work on that somehow, getting that into FHIR, HS7 FHIR, we also thought about, okay, I mean, when we touch it once, why can't we make it more usable and properly annotated with SNOMED? So this is essentially what we're coming from. So this is not an official SNOMED mapping that we did for the cancer registries, but it's more like we understand our position as researchers to just help out and give one first draft out for public discussion. And so I asked some of my colleagues to help me, or I was not one of the mappers, but I asked for help. And so we got one mapper, then another one for quality control, and then two other junior ones joined, and suddenly we were 4 people, each individually mapping. We didn't have many rules, as you can see here, and that's one of the issues we ran into, but we tried to just have a look at the pre-coordinated concepts. We know about the value of post-coordination, but for the first draft, we really wanted to stress or to go for pre-coordinated concepts, and we basically did the mapping work in February to April 2024, so 1.5 years ago. And just to give you a very quick tour around what actually happened, we started that, it was finished in April, and then we basically ran out of resources. We discussed what to do now with that. In the cases where we had different concepts, we discussed it would make sense to synthesize. Let's discuss, let's come up with the patterns, let's decide. But it was really resource intensive, really hard to do. And after all, we also saw value in showing which concepts are more heterogeneous, so in which concepts is the disagreement, and to inform other discussions with that. We then took part in a national working group together with our with the National Release Center people were there, the cancer registry people, pathologists, other domain experts. We had a working group where we wanted to figure this out, but then again, this group ran out of steam, nothing really happened. So we're still sitting on our mappings, we still have no resources, EHDS clock is ticking, and we're still thinking about, okay, but we did this work, we somehow want to contribute, and we're not sure what now the next steps are of getting this into a more public discussion in Germany. And therefore, we now took some time to look at this like a data scientist essentially, and trying to describe our mapping. And that's essentially what I want to present. So we had 4 mappers. The mappers approximately had a completeness of about 70 to 90%, so 69 to 87%. But of course, it largely depended on the module. So the different mappers had different completion rate by different modules. And this totally makes sense. You can see, for example, the orange part in the middle, the adverse events. There's just around 50% for 3 mappers, which shows that there might be something interesting there, that a lot of the concepts could not be mapped properly, could be due to the data definition in the OBDS, could be due to concepts missing in SNOMED. Yeah, and we see that, for example, for distant metastases, these could be mapped completely, whereas other things, yeah, differ by the mapper. And I think it's very important, but also very hard to distinguish in this case between describing attributes of the mappers themselves and behaviors of the mappers and the core difficulty of the item. What we then did, and this is what you do in many mapping projects, we decided to calculate the Krippendorf alpha, which is the intercoder agreement, which means you basically make a pairwise agreement, and you can then say, okay, if on a certain item the mappers agree on a term, then it's very likely that this term is a good fit for that this mapping is a good fit. However, yeah, so we did that, and you can see totally makes sense. You have modules where it worked better, where the agreement was high. You have modules where the agreement was very low. But then it somehow, we discussed it, and it occurred to me, you have to think those things together, because the metrics influence each other. If you have modules where there's lots of missing, the agreement increases automatically, mathematically, and it's just something you have to kind of be aware of and discuss, because when 2 people are, let's just pick the tumor board, we see there's just 2 people mapped and the other one had a very high missing rate. And that's interesting because essentially that could mean 2 different things. If I now give you the additional information that 2 of the mappers have more experience than the others, what does that tell you? It could either tell you the experienced mappers found the fitting concepts and the other ones didn't, and therefore it is missing. Or it could tell you the story that the experienced mappers couldn't find the proper concept and went missing, and the inexperienced ones found something that just matched. And you can't really tell just from the data, but I think that's really I think that's really important to keep in mind when discussing the difficulty of the items. What we also, I didn't want to say we discovered, but it becomes clear when you look at the Krippendorf algorithm. It's not intended to work on 100,000 SNOMED concepts. And what happens is that when you have mappers that map to very similar concepts, that the Krippendorf still gives you a disagreement, the normal Krippendorf algorithm, which is true, makes sense, but I would argue that we had one mapper, for example, who mapped primary tumor to malignant neoplastic disease, and another mapper to primary malignant neoplasm, which are different but very similar in context, and you might come up with a solution this way or this way. So it's not a big difference. Whereas you could have, for example, other mappers going for a body structure, which is completely different. And to account for this difference, there was a paper 10 years ago, they did it with the graph distance base weighting. So what they are doing is they're calculating the SNOMED distance from the SNOMED graph. So you can say you do Krippendorf alpha, but you take into account that some concepts might be closer related to each other in the graph than others. So what you essentially can do, depending on the graph that you're building, you can do the is-a relationship here. So like in the example I just showed, you can say these concepts are 2 path lengths away in the is-a graph when they're closely related, or for example, when they're siblings in the same hierarchy. But when they're in a completely different hierarchy, like disorder and body structure, you might calculate the complete path length over the SNOMED root concepts, so you get very high path lengths. You can also do it with the full SNOMED relation graph, where you would take all the relations into account, where you usually get a smaller, where the path length in general is shorter, and which might also account for the semantic richness that the SNOMED attributes can bring. There is one caveat when you do the graph-based approach, which I stumbled into, because of course the SNOMED graph is a directed graph, or the SNOMED relations are directed, so you have to calculate both length and take the shortest one in this case, because otherwise you will get artifacts with the mapper order that you have. And this is essentially how it looked like after that. So in the lowest, on the lower line, this is the Krippendorf that I showed you on the other slide, and this is basically the one with the is-a and the full relationships. And you can see with the red ones, these are basically artifacts here because these are modules where just one mapper filled out something, so the algorithm was not able to calculate the Krippendorf properly. But in general, you can see that if for some modules, we get really, really good results. So a Krippendorf of 0.9, above 0.9 is, I think, a really good result, which is, of course, not comparable to the lower one, but it shows you that the general agreement on what kinds of concepts should be mapped is really, really high there. Also, for surgery, for example, you see an improvement over the different mapping techniques. Interestingly, we see also decreases, and I'm currently not really sure why exactly this happens. So I will dive deeper into this in the next weeks and months. But for example, in histology, it says approximately equal. And in study, that might be because there are just a tiny amount of elements that are asked, and they are maybe not properly represented in SNOMED. So I think that might be noise. And I think I haven't really yet accounted for the number of elements in each module, because of course every model has a different amount of elements. Yeah, and then if we bring them into order, we can see, okay, because what we're interested in is how can we contribute our work, and what are the most difficult and different and the most heterogeneous modules. And so we saw, okay, we'll probably discuss general health, progression, and histology as the next ones to focus on that. And maybe we're fine with the other ones. And of course, like in the previous talk, sometimes the problems are in the source model, because as you can maybe read here, these are different methodologies for radiation therapy, and as this dataset was growing, they just attached more and more characteristics to single data points, which means that for one data point, because that in practice reduces the number of clicks that someone has to do, but if you like re-import this logic into the data model, then you get really, really aggregated data points. Like for example here, those really long ones where you see no one mapped. This is the approach to control the drug support and the dosage just mixed into one data point, where we can see, okay, with the approach, it is mappable, very likely, but not with the approach that we've taken. So maybe with post-coordination and or the use of another data model like the fire information model, you can kind of start to cluster those things. So this is basically, I was not one of the 4 mappers, but I tried to, because I was working in parallel on the fire specifications, and I thought, I find this so interesting. I'm not able to present all the results, but it's just me going through there and kind of picking the best one that seemed to fit the fire specification I was working on. And we published this 1.5 years ago as part of the Medical Informatics Initiative Oncology set, and make this publicly available for discussion. And we also got some very good feedback from the community, especially from domain experts in radiation therapy or other things that we integrated there. However, this is in no way normative for anything. It's just out there and might be informing other people. And the nice thing is that time also solves some of the problems, because we decided not to map things like ICD-10 and OPS, because there's other people responsible for that. And we decided not to map TNM because TNM was not, or was at that time not at all available, because it was removed. The HACC was removed for some time. And in Germany, I think most of the TNM that is used is UICC TNM anyways. But yeah, now 1 year later, we luckily have that, and we basically updated the mapping in this part. So yeah, when we do the mapping now, maybe it would be even better, because of course SNOMED, especially after the monthly changes, might have more concepts, so we will improve that. But it's nice to see that things improve without us doing anything. So thank you very much for everyone who worked on that. So what we're actively trying to do now is we're suggesting additional concepts. We will come up with something that might have been added either to the German extension or to the SNOMED International. We will try to change the OBDS. It will not happen overnight, but when we move over to FIRE, I'm pretty sure we will improve the data model that they're currently using. Like I said, we're trying to support the fire reporting in general. A personal pet project of mine is I will try to integrate the oncology data in the national EPA, the National Electronic Health Record that everyone has, trying to help there. And the last part, and this is why this topic in general, and to think critically on methodology about mapping. We heard a lot of mapping AI talks, and a lot of companies and products are doing that. And this is very important, because the story that I just told is basically filled with, we have no resources to do that. I think AI can be really helpful, but we kind of have to really think methodology about where to use it, how to compare them. And I think with those metrics that have started to, the heterogeneity mappings, you could think about comparing AI agents to people, comparing AI agent performance amongst themselves. And I think that's really something that you have to do. You can't never rely on just one person or product mapping on something, but you always have to think in cohorts and studies and experiments. And then essentially, I will also try to pull the things that we've worked over. I'm part of the European Common Cancer Model project, where we try to come up with a cancer model that can be used. Also, we're working on a logical model that will be represented in FIRE profiles, but will also have mappings to HOMOC, for example. And I'm also part of the Phoenix initiative, which will use this data model to basically work on prototypes for clinical decision systems and clinical guidelines and other things, because coming up and promoting standardized data models for the EHDS will enable us to have a more reliable system for working with these very local systems at the moment. Thank you very much.
Thomas. We will now begin the question period. As a reminder, if you're in the room, please use the microphone provided here. Ask your question so that everyone can hear clearly, because we are doing the recording as well. Any questions from the room? Okay, can I? Yeah, go ahead.
Hello, my name is Andrea Riedel. Thank you very much for your nice talk. I have a question to your slide regarding the semantic distance. I saw some negative Krippendorf alpha, so maybe you explain a bit the reasons.
This one?
Yeah.
Yeah, I'm not 100% sure what happened there. So in the residual state, is this the case that there was just one mapper for most of the concepts? And usually a negative Krippendorf alpha is some hint on a systemic disapproval, right? That there's some bias in the data that tends to, for example, if you try to answer always wrongly in a test, then this is a systematic disapproval. And usually this doesn't happen in SNOMED because SNOMED is so huge, and it's really hard to prove that you're with purpose not picking the right concept. I think this might be, in this case, an artifact because of the high missing rates. But I have to look deeper in that. Might be a mathematical artifact of the algorithm. Yeah, one of those two. I will check it.
Thank you very much.
It's so good to see a graph database used again. Two questions. One, what graph database architecture did you use? And two, more on your methods. So how do you account for axes in SNOMED that have a concept model and may be very, very deep? And how does that also compare with your hierarchies that have no concept model or are only defined by ISAs, but could be deep? How does that affect your algorithm for likeness?
Interesting questions, both of them. So I used a library that my colleagues from Lübeck wrote. So I did not implement the graph builder myself. I think there are a couple of different ones. No, I'm not able to answer the graph building question. I can send it to you if you're interested. But yeah.
I'm curious more than anything, but that's okay.
Yeah. And no, this is not compensated. This is not compensating for the different depth of the different concepts, which, from my understanding, shouldn't be a problem for the full relationship graph, because you should be, in theory, but I'm not entirely sure, depending on the concept, should be able to find a short way through even deeper graphs. It is an issue if you have the distance just with the assay relationships.
So question on the histology as well. So it's an underdeveloped aspect, or it's a it's an area of the terminology that's not up to date, as you know. And so I'm wondering if that is not part of the disagreement component, because the relationships even within a particular histology may be related to another, but not represented well in SNOMED yet.
I would argue it's not. That doesn't state that SNOMED is bad. No. I think the issue here is more on the OBDS side. So the concepts that they're asking are so specific or German or whatever, and that it is not represented in SNOMED in this case, like grading. But some of the data elements are also administrative, like the accession number. I'm not sure there's an accession number in SNOMED. Doesn't have to be, but these might be some of those might be artifacts of administrative data being asked. Like, for example, in the surgeon module, that was just surgeon. And that's not really a clinical data point that is worth mapping.
Do you think the graph aspect could be used to find quality issues in SNOMED and identify areas that in our quality initiatives might not necessarily be found as easily by humans? You think?
Yeah, I guess so. Well, you need humans to assess that some path lengths should be shorter than they are, or you could think about two concepts having a long path length. Adding another component or another relationship to maybe shorten the distance. Yeah.
Young, it's all for you now. You can run the graph. Thank you.
Actually, the last question is really I want to ask as well, because we are working on the quality improvement initiative to look at the consistency of modeling, and sometimes, the human error, you just put an incorrect value. Sometimes it just forgot or not sure this attribute should be used in the model or not. And it would be interesting to see your methodology here. Would it be possible to detect some anomalies or not? I think that'd be a good thing to after have more discussions.
I will publish the scripts and everything, so it's not yet. I still have to refine it a bit, but yeah, it will be made open source. GitHub.
Any other questions? Okay, that concludes this session. To our online dedicates, please welcome to remain here for the next presentation in this stream, or you may navigate to another session where the event lobby. Thank you, Thomas, for this excellent presentation.